Okay, now if we have exponential and logarithmic functions, we would like to pretty much solve these equations before we tackle the applications and conclude this chapter. So to solve equations, we aim for those first. Then if all fails, we try the definition. We could use a definition on anything, but if I can make the exponentials with the same base equal, the powers are equal automatically. If I have two logs and the bases of the logs are equal, the arguments are equal automatically. That's a shortcut to this. This will solve anything. Those are shortcuts. Both of those are. So when I look at example 1, and there's only one example in this whole section, and I have a whole list of questions to do. All of these awesome problems we're gonna do. Well, solve. You can solve any way you want. I see an exponential. I aim for this. Can I make the bases the same? Well, yeah. I could make that a 3 by simply doing what? Moving this up. What's the price? Now that the bases are equal, the powers must be equal. You don't have to check, but you can. If you put 0 right there, that'll be 3 to the negative 1, which is 1/3. Here, there's no way of making a 2 an exponential with a base of 5, so I use logs. If I log both sides, again, this is instead of using the definition, now I could log both sides. What base should I use to get rid of the exponential? Well, the 5. Or you could use the definition, of course, and we just did this. This is the exact answer. If they ask for an exact, this is exact answer. If they want an approximation, I need my calculator. I'm going to take natural log of 2, and I could use the shortcut on my calculator. I want to use what's in your calculator first until we get the hang of this. Divided by natural log of 5, change of base, 0.430. 677. And I could check if I am taking a test. If you take 5 and you raise it to the 0.430677, 2.000. The reason you're getting over because we rounded up. So you'll never get exactly 2. Either a bit above 2, or if you round down, it'll be 1.99999. If I'm solving this equation, this is an exponential equation, right? So the way you solve any equation in math, you isolate the name by itself. Since this is an exponential equation, I need to isolate the exponential by itself. I divide by 3 both sides. These are all the different applications you're going to come across in the next chapter, section. And if I can't make this into a base of 3, I would use my logs. 3t will equal the log. The base of the exponential is 1.045. This is what we did on the first assignment. And I would divide both sides by 3, and that takes care of business. And t would be a log base 1.045 of 3 divided by 3. That's the exact answer. If they ever ask for an exact, that's how you write it. And if I'm going to use my calculator, I will write it as I see it, parentheses, natural log of 3 divided by natural log of 1.045 divided by 3. One shot. 8.319, 8.319, 628. There it is. So again, the next section is applications, and in there you're going to solve one of those, either an exponential or a logarithmic function. Logs are coming up for dealing with exponentials. Now, same deal, this is an exponential equation. Well, I need to isolate the exponential by itself, divide by 3 both sides. 3 300 100 times. Subtract 4 from both sides. And that is 96. Now 96, let me see if you could write that as exponential with a base of 2. Then that's pretty good. 2 divides 9. 2 divides 9 4 times. 48. 2 times 24. 2 times 12. 2 times 3. So I can't write it as an exponential with a base of 3. With a base of 2. So I could have figured that out from the beginning. Have I, took 9 plus 6 is 15. 3 divides 15. So what am I going to do? I'm going to go for logs. Log base 2 of 96. That's the very first lecture on logs, right? That will be section 4.3. And x will equal log base 2 of 96 minus 2. That's the exact answer. In your science courses, they might ask for exact answers or approximation when I learn both. So I'm going to take natural log of 96 divided by natural log of 2 minus 2. And all of that is 4.548, 584, 584, 963. It seems the 6 decimal places were always rounding up. I wonder if that's always the case. Second problem we want to look at is E, and the same deal. This is an exponential. At first glance, you might be thinking, oh, got it, I can make that into an exponential with a base of 3. But you need to isolate the exponential by itself. That's not possible anymore, so I know that 2x minus 1 equal log base 3 of 7. So 2x equal log base 3 of 7 plus 1, and x would be log base 3 of 7 plus 1 all over 2. That is the exact answer. And I could use my calculator to approximate that, and here it is. Parentheses, another one. So I'm going to take natural log of 7 divided by natural log of 3 plus 1 divided by 2. 1.385, 1.385, 622. Okay, and if I look at the last problem, or the third problem, well, that one seems a bit trickier than usual. Well, that's okay, because I could say that's 3. So I could say, you know what, this requires a bit more algebra than the tradition. So I'm trying to get this into 3 squared into an exponential with a base of 3. And this will be 3 to the 2x plus, and here's the catch. If I said take a to the x times a to the y, isn't that a to the x plus y? If I go right to left, I could go, if I go left to right, I go right to left. If I have a to the x plus y, can't I say that that's a to the x times a to the y? We're not used to that. Can't I say this is 3 to the 2x times 3 to the 1? And now what? Now it gets a bit tricky. I have one of those plus 3 of those. Isn't that 4 of those? Right? Or you could factor, if you want, 3 to the 2x out, and you will have a 1 plus 3, which is the 4. Now this is an exponential function. Isolate the exponential by itself. Log both sides with base 3. and x would be log base 3 of 25 divided by 2 all over 2. That's the exact answer. If I throw this in my calculator, I'm looking at parentheses natural log of 25 divided by 2, or 12.5, it's up to you. I need one more parentheses. That's okay, I'll add it at the end. Divided by natural log of 3 divided by 2. 1.149 509. That's what you replace this x with, combine, you get a number very close to 50, most likely 50.0001. And here, this problem, this is called a logistic equation. You don't need to know the name. Here I cross multiply. Isolate the exponential by itself, so subtract 4 from both sides. Divide by 4 both sides. Transform to log. And divide by a negative 2. That is the exact answer. And if I throw this in my calculator, I could figure out what that would be if I take natural log of 1/4, 0.25, or you could write 1/4 if you like. Yeah, I've seen students complain about that. Here we go. As you see it, not a problem. Divided by natural log, divided by 2. It's already a natural log. Negative 693. $147. Oh, this one didn't. Nice. So it doesn't always round up. It's a coincidence. This problem. This is quadratic. I could factor this into e to the x, minus, oh, I messed up, I'm sorry, I meant for that to be a 2, minus 3 plus 1. So e to the x plus 1 equals 0, that means e to the x equals negative 1, that's not possible, exponentials can never be negative. E to the x minus 3 equals 0, e to the x equals 3, x equal natural log of 3 would be the answer. If I want to approximate it, simply natural log of 3 equals 1.096, 0986, that's what I thought it says, 123. Oh, that's more than 6 decimals. That's okay. Over is okay. And here, well, this is a negative power. That's e to the x plus 10 over e to the x minus 7 equal to 0. The LCD for this problem is e to the x. So multiply this by e to the x top and bottom, this by e to the x top and bottom. That would be e to the 2x, or e to the x squared, that's what this is, plus 10 minus 7 e to the x equals 0. Again, this is quadratic. So I could factor that e to the x minus 5 into e to the x minus 2 equals 0. So either e to the x equal 5, which means x is natural log of 5, or e to the x equal 2, which means x is natural log of 2. And if I wanted to simplify, I could say just natural log of 5, 1.609, 438, and natural log of 2, the same deal, 693, 147. I get to this problem. Well, it looks cluttered. If I get everything on one side, 0 on the other side, it would look a bit nicer. If I factor 3 to the x out, so if I factor further, so I could say 3 to the x equals 0. That's impossible. X will be a -4 or a -1. So factoring is a big key.